Knowing the inertia of your system is important. Why? Because the more inertia your system has, the more force will be required to get the system moving. And that is what tells you what size motor you're gonna need. So it all starts with inertia. The bad news is, inertia isn't always the easiest thing to figure out, especially in a typical real-world complicated system. The good news is, the SureServo2 Pro software has a built-in inertia estimator that measures the actual inertia it sees in your system. Let's do a quick example so you can see how this works. I'm using the same hardware as we used in the quick start video, except I added a 4.5-pound steel pulley to give us plenty of inertia. This pulley has a 5/8-inch bore, and the servo motor has a 14mm shaft, so I just printed a cylindrical spacer to make up the difference for our quick little demo. I've already launched the SureServo2 Pro software and connected to the drive. When I click on the inertia estimator, I get a dialog telling me it's going to switch the drive to position mode, it's going to mess with these parameters, and it'll put everything back when the drive's done. And it warns us that if things don't complete normally, the drive will be left in an unknown state, so you should reboot it to get things back. I would also suggest that you save a copy of the parameters to disk before you start, just in case. The software sees my drive isn't enabled. I can enable it here or using my system's panel switch. I prefer to do it here because the software will automatically turn it off when the estimator's done. This reminds us that if we have a motor with a brake, make sure it isn't engaged. Here we want to specify the motor's speed and ramps. You want to pick numbers here that are representative of what your system will be doing. I can tell you 20 RPM is way too slow to get a good inertia estimate. That's only 1/3 of a revolution per second. That's really slow. So I'll crank that up to 1000 RPM for our simple little demo. The ramps need to be fast enough to give us a good bump when we change direction, or better yet, need to emulate what your system will be doing. This is fine for us, so I'll leave it alone. And if you're using S-curves, put that number here. I'm going to leave that at 0 so we get a good hard change in direction to put a little extra stress on the system. Download those values to the drive. Now we need to specify 2 positions. In a linear motion example, you would start at position 1, ramp up to the jog speed specified up here, and then ramp down to position 2. It's important that you leave enough time for the system to get up to speed. If you don't, then the ramps won't have enough time to complete, and the inertia estimator will throw a bunch of errors at you and shut down. Looks like my motor is currently at this position, and I could move that around using these jog buttons. I don't have anything that needs to be moved, so I'll copy that to position 1 by clicking on this button. Next, you hold down the jog buttons to move your system to the next position. For our demo, I'll just rotate the pulley a few times and copy that to position 2. Just make sure you get at least 1 full rotation. The estimator won't work unless you do. Hit the Start Moving button. The drive will move the motor back and forth between position 1 and 2 over and over until it has a good handle on the inertia. I did a factory reset on this drive, so it's not tuned, which means it'll take a little while to come up with an inertia estimate. If you do this on a tuned drive, it'll come back real quick with an answer. When the estimator feels like it has a good handle on the inertia, you get a green check mark. J stands for inertia, so this says the load inertia is around 37 times the motor's inertia. That's incredible and way beyond the capabilities of most servo systems. Normally, you want to keep this mismatch to 3-to-1 or 5-to-1 or maybe even 10-to-1. So it's pretty amazing that our little demo can handle this large of a mismatch. You can also see this in the auto-tune video where we tuned the servo for this exact pulley. And it's the SureServo2's huge 3.1 kHz bandwidth that makes all of this magic happen. Hit this download button to update the parameters. And while I didn't do it here, you will want to read the new drive parameters back into the SureServo2 Pro workspace so it has the updated parameters when you save it. Now this is just a simple example of what can be done. How much inertia mismatch your system will handle will depend on your acceleration and deceleration ramps, your speed, your system configuration, etc. The good news is you now have a quick and easy way to measure it. But how accurate is it? Just for fun, I went to the Automation Direct website and looked up the pulley we're using. One of the cool things about the Automation Direct website is you can view the part in 3D right on the website and download it in any of 60 different CAD file formats. I downloaded one and brought it up in a CAD program called Onshape. The cool thing about Onshape is it's entirely web-based, so you don't need a fancy computer to use it. and you can use it for free. I specified the material to be steel, and then click this guy to get the inertia matrix. We want the moment about the y-axis. If I then go to the servo's data sheet, I see the motor's inertia is 48. So the math says, in a perfect world, we should have a 35-to-1 ratio between the pulley's inertia and the motor's inertia. The estimator saw around 37-to-1, which includes real-world things like friction of the motor bearings, imbalances, inefficiencies, etc. So yeah, that's pretty darn close. The point is, the SureServo2 system does a really great job of handling extreme inertia mismatches like this because of its 3.1 kHz bandwidth, which is just one more reason it's such an incredible value. Click here to learn more about the SureServo2 system and to find more videos like this one. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.